this tutorial video is going to be looking at ionic compounds that have polyatomic ions contained in them. So we'll start off by actually addressing what is a polyatomic ion. And polyatomic ions are ions where atoms sort of naturally bond together and behave in a unique way. And the way that I often explain it is that it's sort of like that clique of friends that when they come together, they're inseparable and they have this unique sort of characteristics. And these atoms that come together, that typically come together, tend to have a charge that represents more or less the number of valence electrons you would see. So let's take a look at what some of these polyatomic ions actually are. So these polyatomic ions, as you notice in these circles over here, is that they are different atoms bonded together. And you're going to find that these different atoms have a unique charge. So if you look at, for example, I'll go ahead and grab my pen. If you look at, for example, nitrate is this one right over here. It has the formula of NO3 minus. So you notice that you have one N, thanks to the N, and then you have 3 oxygens. And overall, they have a minus charge, which we assume to be a -1. You have another common one is sulfate. Sulfate you see is, is SO4 with a -2 charge. And you're going to notice that with SO4, that means you have one S, 4 O's, and if you take a peek right over here, it has a -2 charge. All right, let's try another one. Let's try chromate. That's this one right over here. Chromate is CrO4, and it has a -2 charge. So with CrO4, remember those subscripts tell you how many atoms are attached to, are bonded together. We have the Cr with 4 O's, and they have a -2 charge. All right. Now, in chemistry, you are going to be given a chart where you can always refer back to what these chemical names are and their chemical formulas as well as the charge. But one of the things that you're going to notice with all polyatomic ions is that all polyatomic ions tend to end with 8 at the ending, or ite, okay? There's always a T involved. Remember that in our ions that we've been working on beforehand, those anions, they always had an IDE ending. But when we're dealing with polyatomic ions, we're always having an ATE or ITE ending. There's one exception, and I'll actually talk about that exception later on in this video. So just a reminder that if you have an ate or ite ending, that you are dealing with a polyatomic ion. So let's take a look at some examples again, so you can see what it looks like in terms of valence electrons. So just as a reminder that when you have any sort of subscript, a subscript are the small letters at the bottom right-hand corner of a chemical formula or a chemical symbol, that tells you how many are bonded together. So this is, and on the top right-hand corner, so at the very top, that tells you the charge. So if I see SO4 with a -2 charge, remember that small 4 that's at the bottom of the oxygen tells me how many oxygens are bonded with sulfur. So I'm going to go ahead and draw that nice and simple. It makes no difference how you draw it. I'm going to have one sulfur with 4 oxygens surrounding it. Okay? Now, The reason I put 4 oxygens surrounding it is because that subscript 4 tells me that I have 4 oxygens that are bonded with the sulfur. Now it tells me it has a -2 charge. Because it has a -2, just like what we've been working with before, that tells us it has a total of 6 valence electrons. Remember, because it's going to be gaining 2 electrons. So that -2 charge tells us that it wants to gain 2 electrons, those negative electrons. And that means the reason why it wants to gain 2 is to get that full valence shell, which is 8. And so for that reason, I'm going to be drawing 6 valence electrons. Okay. All right. So now let's try nitrate. So nitrate, let's see how you're going to do. Think about how many nitrates you're going to bond and nitrogens and how many oxygens. And just to help us out with these names, just so you remember, this is called sulfate. And I know I didn't mention it before, but polyatomic means many atoms bonded together for an ion, okay? So do you notice that ATE ending for sulfate? That's because we have many atoms bonded together. This here is nitrate. Again, this is nitrogen and oxygen. You've got many atoms bonded together. Okay, so ask yourself, how many nitrogens are you going to draw? How many oxygens are you going to draw? All right, if you came with the answer that you're going to be drawing 1 nitrogen with 3 oxygens surrounding it, you are correct. There we go. All right, that 3, remember, is because of that subscript. Now I have a minus charge, just 1 minus charge. Whenever you see that minus charge, we assume that it has a -1 charge. All right, so then you need to ask yourself, how many valence electrons does it have if it wants to gain 1 electron? Remember, 8 is our favorite number. So if it wants to gain 1 electron to make that full valence shell of 8, it must have started with 7. So I'm going to draw 7 valence electrons. Remember, you always draw 1 in each region first, and then you start pairing them up. Okay, so here is our nitrogen with its 7 valence electrons. Let's try the last one. We've got phosphate. Okay, whenever we again see anything that has more than 1 type of atom as an ion, we call that polyatomic, and we're going to end with usually an ATE ending. As I said, you will always be given a chart where you can refer back to that. So in this case, next question you're going to have to ask is, how many phosphorus and how many oxygens are you going to draw? If you came up with the answer of 1 phosphorus and 4 oxygens, you're right. Okay, there we go, have that bonded together. So now this has a -3 charge. That tells us it's going to gain 3 electrons. And if it's going to gain 3 electrons, how many electrons does it mean that it originally started with so that it can get 8? Well, we know that it wants to have 8. If it wants to gain 3 electrons to get that 8, it must have started with 5. There we go. Okay, so let me just refresh this. This has 5 valence electrons. And the reason I know that is because if I gain 3 electrons, 5 plus 3 equals 8. That's my number that I want to get get that noble gas configuration. And for this one, I know that I have a -1 charge. That tells me that I had 7 valence electrons to start off with, because by just adding 1, it gets that full valence shell. Okay, so that's how you kind of work through polyatomic ions and their charges. So now let's work on an actual example. So let's say, for example, we have lithium combines with carbonate. All right, so let's actually identify who the characters are. So I have lithium, and lithium is number 3 on my periodic table. I look at number 3 on the periodic table. It tells me I have 1 valence electron. There it is. So now I'm going to look at my chart. I'll go ahead and refer back to the chart and look at carbonate. So I see carbonate is right over, let me take a moment to find it. Oh, I see it. So carbonate is right over here. So it shows me that it's carbon with 3 oxygens and it has a -2 charge. So let me go ahead and write that down for myself. So as you remember, it was carbon with 3 oxygens. There we go. So I'll just write a reference. And it had a -2 charge. So we need to draw the number of valence electrons that it starts with. Remember, it wants to gain 2 electrons to get that 8. So that means it must have had 6 valence electrons because it's going to want to gain 2. So in this case, lithium can give its electron to carbonate. Lithium is content. However, carbonate isn't content. It has not reached that noble gas configuration. So that means I'm going to have to include 1 more lithium. And that means now both of them have reached that noble gas configuration. And to write down the name, or the chemical formula, excuse me, I'm going to say Li. And then I'm going to count how many lithiums I have. I have 1 over here and 1 over here, so that's 2 lithiums. And then I'm going to write down carbonate as it's written, CO3. Notice I do not include any charges in my chemical formula, all right? Because remember, chemical formulas are neutral. And the name of this is going to be lithium carbonate. So I just call it exactly what it's called on that chart. All right, so we're seeing many of the same strategies that we've been using all along, but we're now just using polyatomic ions. So let's try one more. We have magnesium. So magnesium is number 12 on the periodic table. And when I look at magnesium, it has 2 valence electrons. There we go. Remember, do not pair up your valence electrons until each region has 1. So this is one of the few exceptions where it has an IDE ending, hydroxide, and we use it a lot, so that's why I wanted to present that. Hydroxide is this polyatomic ion right over here. There we go. And it is 1 oxygen and 1 hydrogen bonded together with a -1 charge. Okay, so just a reminder, we saw that on that chart it has OH with a minus. So that would mean that you have 1 oxygen and 1 hydrogen. And because of that minus, that tells us it has a -1 charge, which means it wants to gain 1 electron or will gain 1 electron to have that full valence shell, which means that it had 7 valence electrons to start with. So I'm going to draw those 7 valence electrons. Remember to pair them up after you've got 1 in each region. So again, same as what we've done before. This magnesium is going to, for this magnesium, we can give it 1 electron, and the OH is now content, but this magnesium still wants to lose the other electron. So we're going to have to give it another OH. So let's include those valence electrons. Okay, and it works out beautifully that if you give magnesium 2 hydroxides, it's going to be able to lose all of its electrons. Now take a look how I would write this chemical formula. So we have magnesium, just one of them, so we keep it as is. But do you notice how you have 2 OHs? We need to represent that in a way. So what we're going to do is we're going to put it into parentheses. We have OH twice, okay? So this parentheses shows that you have 2 sets of OH. You do not use parentheses for single elements. You just use parentheses for polyatomic ions. And this would be called magnesium hydroxide. All right, we're going to work on one more. This is aluminum combines with sulfate. So let's start by drawing aluminum. Aluminum is number 13 on the periodic table, and it tells me that it has 3 valence electrons. So I'm going to take a look at what sulfate, remember that ATE ending tells me or gives it away that I have a polyatomic ion, and you'll notice right over here I have my sulfate. It is S with 4 O's with a -2 charge. And so let me write that down. Sulfate SO4 with a -2 charge. So that tells me I have 1 sulfur and 4 oxygens bonded together. And that -2 charge tells me that it's going to want to gain 2 electrons to have a full valence shell of 8. So if it just needs 2 more electrons to get 8, that means that sulfate had 6 electrons when it started. Okay? So here we have a situation where aluminum can lose its 2 electrons to sulfate, but aluminum still needs to have 1 electron that it wants to get rid of. So let's go ahead and give it another sulfate. I'll go ahead and give it its 6 valence electrons again. And that works out fine that now aluminum has lost all of its valence electrons, but sulfate still wants to have more electrons. So we're going to give it another aluminum because aluminum wants to give its electrons away. There we go. And so now that sulfate has its last electron to make a full valence shell, but aluminum still wants to get rid of 2. And so that's where we're going to lastly give it 1 more sulfate. Again, I'm going to give it 6 valence electrons. And it beautifully works out that now aluminum can lose all its electrons and sulfate can gain those 2 electrons that it wants. So now we need to write it down as a chemical formula. So for the chemical formula, I'm going to count the number of aluminums I have. So I have 2 aluminums, so it'll be Al2. Remember, I'm going to show that there are 2 of them. And then notice I have 3 sulfates. So I'm going to put sulfate into parentheses. Remember, I do not include the charge. And then I count how many of them I have. I have 1, 2, and 3. Okay, so that is my chemical formula for aluminum sulfate, and the name is aluminum sulfate. That ends our tutorial for ionic compounds using polyatomic ions.